Hello everyone, we are from Group 2 and today we would like to present our mini project titled Smart Heart Monitor. Let me introduce myself. My name is Raymond Surya Angorsito.
My name is Vanessa Laurel Haryanto.
And my name is Christopher Matthews Tiawan.
According to Centers for Disease Control and Prevention, in 2022, approximately 670,000 deaths in the US are primarily caused by hypertension. Additionally, according to population health survey done in Hong Kong, 27.7% of people was diagnosed with hypertension, whereas 47.5% of them are undiagnosed before. That just goes to show that it is essential for people to regularly monitor their blood pressure. Therefore, the Smart Heart Monitor aims to give the opportunity to people to monitor their own blood pressure so that they may determine their current health condition and prevent things from going worse if were to be detected an anomaly in their blood pressure. We will also give the benefit to users to keep track of their recorded systole and diastole such that the users can compare their current one with the previous one.
Next, I'm going to explain the foundation of the blood pressure. Blood pressure is the force of blood against the artery's wall and is detected in two numbers. The first one is the systolic blood pressure, is when the heart beats or the heart muscle is contracting, and the second one is the diastole blood pressure, is when the heart rests between beats or when the heart muscle is relaxing. Next, I'm going to explain the blood pressure range, and it is described in the table. The first one is the normal blood pressure range is 120/80. The 120 value is the systolic and the 80 is the diastolic. Next one is the hypotension blood pressure range, which is less than 90/60. And the hypertension blood pressure range is greater than 140/90 and is measured in millimeters mercury. I'm going to explain the principle of blood measurement. The blood measurement is measured in millimeters of mercury or mmHg, and the readings are given in pairs, the systolic and the diastolic value. The systolic value is written first, and then there is a slash. After that, there is the diastolic value. For example, it's 120/80, means that the 120 is the systolic value and 80 is the diastolic value. And the device to measure the blood pressure is called a sphygmomanometer. Next. I'm going to explain the sphygmomanometer. There are two types of sphygmomanometer. The first one is the electronic or the digital one, which is shown at the top picture, and it can show the the pressure readings digitally and automatically detect the systole and the diastolic value. And the second one is the manual. The manual is shown at the bottom picture, and we need to manually inflate the cuff and also detect the systole and the diastole using a stethoscope. And basically, a sphygmomanometer works is when a cuff is wrapped around your upper arm and it's inflated until no blood can flow in the brachial artery located in the arm. And then the systolic blood pressure is detected when the first heartbeat after the cuff is slowly deflated, and the diastolic blood pressure is the stop of heartbeat when the cuff continues to deflate. Thanks. This is the oscillation in cuff pressure. As we can see, the first one is the systolic pressure. It is detected is when the first heart beats after the cuff is slowly deflated. And the diastolic pressure is when the heart rests between beats. Okay, next one.
So as we can see, we want to understand the principle and the background of blood pressure measurement between and sphygmomanometer. And we also want to understand the connection of the sphygmomanometer with the microbit and the jumper board, which aims to implement the principle of blood pressure measurements. We also want to produce features on blood pressure monitors, which can show the systolic and diastolic pressures and warn the users about the condition of their current blood pressure. The apparatus and materials that we used are microbit version 2, lab kit, power supply, air pump or valve kit, connected with sphygmomanometer, jumper wires, and USB Type-B cable. Next,
I'm going to explain the lab kit connection. We use three devices, which is the microbit, the lab kit on the jumper box, and the blood pressure sensor. The microbit and the lab kit is connected through to the H connector breakout board. And in the microbit, the pin 15 is connected to the R LED input in the jumper box to power the red LED. The pin 9 is connected to the green LED input to power the green LED. And the pin 19 is connected to the serial clock line or the SCL. And pin 20 is connected to the serial data line or the SDL. And the SCL and the SDL is used to power the OLED display. Next one is the pin 3 volt is connected to the plus 3.3 volt in the jumper box, and the pin 0 volt is connected to the GND or the ground in the jumper box. And the blood pressure sensor is placed in the lab kit, technically in the breadboard. The 3.3 volt pin in the blood pressure sensor is connected to the plus 3.3 volt in the jumper box, and the ground pin is connected to the GND in the jumper box, and the 5 volt is connected to the plus 5 volt in the jumper box. In the microbit, the pin 0 is connected to the heartbeat output in the blood pressure sensor. The pin 1 is connected to the blood pressure output in the blood pressure sensor, and the pin 8 is connected to the air pump input, and the pin 2 is connected to the air valve input. The pin 8 and the pin 2 is used to automatically air pump and also air releasing.
So our first features is LED lights. So we connect red LED lights to indicate hypertension and hypotension disease. We use red.right analog function to indicate the red and green lights. And the green LED lights, we connected it to indicate the normal blood pressure. Next, the second features are speakers. So we connect speakers to output hypertension sound to indicate hypertension, and hypotension sound to indicate hypotension, and also normal sound to indicate normal blood pressure. And the third features is to display text on the OLED. So after the measurement, we will display the blood pressure number on the OLED, and after that, it will followed by the systolic and diastolic number pressure. And after that, after the second measurement, we'll also display the previous systolic and diastolic number pressure on the OLED display. And when the measurement indicates hypertension or hypotension, we will display hypertension or hypotension text on the OLED. And we will also display the suggestions such as exercise, no smoking, reduce caffeine, and etc. But when the measurement indicates normal blood pressure, we will only display normal text on the OLED, and after that, we will display a stem on the OLED display. Next.
So for the fourth feature, we use the microbit 5x5 LED display. It will display images according to the diagnosis made by the citizen. For example, it will display an angry image for indication of hypertension. It will display a sad image when it indicates a hypotension, and happy when the systole-diastole range is within normal range. In the fifth feature, the smart heart monitor is able to store and display the previous record of blood measurement. The working logic behind this is that we initially set two variables to 0 and one variable to a true Boolean value. When the recordings have been done and the system is done with all the diagnoses and warnings, the variable called requirement value is changed to false, which activated the if condition at the end of the while loop to ask whether the user wants to remeasure their blood pressure. If they want, the previous systole and previous diastole variable is assigned to the current systole and diastole, such that it may be displayed in the next measurements. In the sixth feature, we implement automation in the air pumping and air releasing in the sphygmomanometer. Since we already connected to the air pump pin and the air valve pin to the microbit, we are able to send signals to actuate the pumping and releasing, such that the pumping is triggered when the users press the button A on the microbit at the start. It will pump for 5.5 seconds and stop pumping after that. The air will be released fully after the whole diagnosis has been done, which can be seen from the code pin2.write_digital0, where the pin 2 is connected to the air release pump. After this experiment, we'll have several suggestions for people who want to pursue more or continue the system to improve its overall function. One of them is to implement wireless control of the blood pressure monitor. Second is to add error handling measurements to reduce inaccuracy of measurement due to external factors such as unnecessary movement by the one being tested. And the third one, we want to suggest for people to be able to compute heartbeat and detect systole and diastole automatically. In conclusion, the smart heart monitor is designed to automatically pump and release air from the sphygmomanometer. Although users have to do it manually, it is smart enough to be able to classify those systole and diastole into three different diagnoses, which is hypotension, normal, and hypertension, and give messages accordingly. The system is also able to record previous systole and previous diastole obtained from previous recordings, such that the user may be able to compare the current one with the previous one. So here's the working principle behind our system. When button A is pressed, it will automatically pump the sphygmomanometer. Here we record it manually, and in the OLED we can see the systole value and diastole value. It will then classify into the diagnosis and display the messages accordingly. Here you can see the previous systole and diastole recorded from previous measurement. These are the references used for the presentation. Thank you very much.
Thank you very much.